In this episode, we're going to talk about milliohmmeters. Most of us cannot afford a milliohmmeter. They're pretty darn expensive. I have an alternative to spending all the money and still have the same general performance. It's going to be a little less because it's not completely calibrated. But compared to an ohmmeter, and I imagine everybody owns an ohmmeter, it is light years advanced from that as far as measuring high current devices. So let's go ahead and let's measure a couple things with an ohmmeter, and then we'll go ahead and our milliohm meter utilizing these Kelvin clips. I will explain a little bit later on the whole process for that. But let's go ahead and run a test here. So we're going to set up our ohmmeter. I'm going to do is I'm going to zero it out. It's pretty darn close. These are some pretty good leads here. Okay, so we're zeroed it out. I'm going to go to this relay here. These connections are tight. And I'm going to hook up here. Now, of course, there's nothing because the relay is open. I'm going to energize the relay. Okay, we can see we have 900 milliohms of resistance. We're not 100% sure. We're not pushing a lot of current through there. But we could say, yeah, I guess it looks okay. It's under an ohm. Now we're going to take our milliohm probes here that are actually Kelvin clips. I will have to calibrate them first. Okay, they're zeroed out. I'll give it about the same amount of time here. So we'll say 153 millivolts. So if we had 153 millivolts, that would get us down to 0.0153 milliohms. Well beyond the range of what a conventional ohmmeter. So we're getting very, very detailed information. Okay, let's look at this here. So if we're at about 100 milliohms, potential for lost power. That's what the diagnostics would be on. So in this particular case, this was a solenoid out of an ATV, and it would crank slow when it was cold. And I was able to check it, but it was almost impossible to get to it to do a voltage drop check when it was actually in the chassis. You could see this technique by simply setting up a circuitry on your workbench. Is very accurate, a real good methodology to actually go ahead and check a component. So let's talk about what we got here. Well, everybody understands a conventional ohmmeter. Let's go ahead and talk about the Kelvin clips. So what I have set up here, and I will unhook, so we can start over from the beginning. What we have is a special probe clamp called a Kelvin clip. It utilizes two conductors. So one's going to come from a dedicated power supply. The other one's going to go to your meter. They both intersect here at the jaws. That way we're eliminating all voltage drop within the leads themselves. This here is a dedicated power supply. So this is simply a pulse width modulated power supply that is relatively inexpensive and easy to set up. So I'm simply putting in my system voltage, in this case here about 14.5 volts, and it goes in, and then I have an adjustment on there to set it up for 10 amps. So the goal here is to have 10 amps, and then through the conductive wire, so one half of this is going to have 10 amps on it, and the other half is going to be monitoring it. So that's the process that's involved. So let's go ahead and hook everything up here. I'm simply using a coil of wire here as a resistor. The only purpose for that is if I'm off a little bit on my adjustment, so I can kind of protect the circuit, so to speak. So one lead is going to go to the power supply, and the other one to our meter itself. Respectively, we have the ground. And now what we're going to do is we're going to put these together. We'll start the meter out fresh. We're going to put these together. But before we do that, we're going to need to do one more thing. We need to verify that we're actually at the 10 amps. So we're going to put this over to the volt position. Take my inductive amp meter. We're going to turn it on and we're going to zero it out. And then I'm going to work on a 20 amp scale. So we'll expect to see 1 volt on the meter when I have 10 amps going in here. So that's 1 amp per 100 millivolts. And this is the one coming from the power. We're going to look at current flow. So we'll hook up just like such. Now I need to attach these together. And it looks like we're pretty close. This pulse width modulated control power supply has been very accurate. I can leave it. I typically set it up, and we're not enough of adjustment here to even worry about. But now I have something that is very, very specific and can push in 10 amps of current across the device that I'm going to check. So let's look at some other items here that might be stuff that you would have no chance of testing with an ohmmeter. So we'll get our amp probe out of here. We know that's correct. We'll get our ohmmeter set up. Now with our ohmmeter set up, we'll go ahead and we're going to zero it out. And we are really close, but we'll go ahead and... So remember, it's pushing a current through the test lead, so it's one of the challenges without the Kelvin clips. Let's get a couple items to check here. First, what we're going to do is we got a double-aught cable, marine grade, and we better assume this is going to be good. There shouldn't be any problem with it. It is brand new. And that's exactly what we'd expect to see. 0 ohms. So we're going down to the 100 milliohm range here, so we can see the 0.0. So represent that would be at 100. Or another way of saying it is the 10th. Now what I'm going to do is I'm going to go ahead and zero this out. Okay, we got 44 millivolts there. And we'll go with 55, let it stabilize here a little bit. So if we have 55 millivolts, so we would be at 0.0055 ohms. By seeing this number here, we feel real confident that the cable is good. The ability to look at that level of resolution is key to this kind of testing. Let's go ahead and check a couple of other items here. Next one here is a short cable. There again, brand new. This is an 8 gauge cable. So we'll hook up our ohmmeter. Again, the ohmmeter is going to give it a clean bill of health. We'll unfreeze this. We'll hook up here. We can see it might have a much larger number. We'll let it search a little bit here. Remember, the number is going to be changing because we are passing current through here. But we'll just stop at about this point here. So we have, in this case here, we have 305 millivolts. So what would that give us? So if we were at 300 milliohms, we'd be 0.0305 ohms. So again, way below the resolution that we could see on our regular ohmmeter. You can see with the quality of the test here is so much greater than using a conventional ohmmeter. So the cost of this is relatively inexpensive. I believe I have around $20, so that's just dirt cheap, for the power supply. And then I have around $20 some into the Kelvin clips. So between the two, I have less than $50 invested in a tool that can allow me to go much greater detail. In future videos, we're going to go in and start doing some troubleshooting with this milliohm meter. So now you understand how it works. We'll be going into a more advanced area of testing. So I want to make sure that you subscribe and comment, and really appreciate you viewing. Thank you and have a great day.